All right, hello, this is Mrs. Nearing, and this video is going to be about a few of the most commonly requested problems from the stoichiometry practice set number 2. So this involves some limiting excess reactant, as well as some stuff about percent yield. So problem solving strategy in general with a limiting excess reactant problem, the way that you spot that it's a limiting excess reactant problem is you're given values for more than one reactant. So they might say, 10 grams of A and 20 grams of B react to make C. So if you're given values for more than one reactant, the strategy is to do two side-by-side stoichiometry calculations and then look at your answers and compare which of those two calculations gives you less product. And the one that gives you less product, that's how much product you're actually going to make. And that reactant that gave you less product is what we call your limiting reactant. The other reactant you're going to end up having excess of, so there'll be leftover sitting around that's unused. Other than that, the strategy is the same. We're using your mole map. So like you might be starting, if you're starting with grams of one substance, your first step would be to find moles using molar mass. Then you would use your mole ratio to convert from moles of one thing to moles of something else. I see a lot of people are missing this step, and this step is really important, and every single Stoic problem should involve a mole ratio step. And then you would finally convert from moles of your final thing to mass, and then you just do that twice. So you'd have 2 3-step Stoic problems, and you compare which of those values makes less, and that's your limiting reactant. There's other ways to approach limiting excess reactant problems, and feel free to use different approaches as long as you are showing your work clearly. This way I found I think is fairly straightforward, so I'm just going to show this method, but again, you can use other methods as long as you're showing your work clearly. All right, so problem number 3 was a commonly requested problem, and it involves this reaction right here. So let's take a look at our balanced chemical equation first and think about what that means. So if we look at it, there's no coefficient here. That means it takes, for every 1 sulfur, we'll react with 4 chlorines and make 4 disulfur dichlorides. So that's basically your recipe for making disulfur dichloride. That's going to be the heart of any stoichiometry problem, is we're going to have to use those ratios, 1 to 4 to 4. Okay, and if I look at this first problem right here, notice how we're given 2 values. I'm given 32 grams of sulfur and 71 grams of chlorine. Whenever you're given 2 values, you know it's a limiting excess reactant problem, and you're going to set up 2 Stoic problems. So first, let's deal with the sulfur. So I've got 32.0 grams of sulfur, and take a look at the problem. Sulfur is S8, so it's one of those examples of a polyatomic molecule. So it's kind of funky, a little different than we're used to. My first step is I'm going to go from grams to moles. So 1 mole of S8 weighs 256.6 grams. So make sure you multiply the molar mass by 8, because there's 8 sulfurs. And then I'm going to look at my mole ratio. I'm trying to find S2Cl2. And my recipe tells me for every 1 mole of S8 that I have, I can make 4 S2Cl2s. So there's where my mole ratio is used in this mole to mole step. Sorry, I left out the mole value there. So 1 mole of S8 will make 4 moles of S2Cl2, and 1 mole of S2Cl2 weighs 135.0 grams. So if I go through and do this in my calculator, I have, what this is telling me is I have enough S8 to make 67.3 grams S2Cl2. Okay, now I can't ignore the second value that's given to me, so let's deal with that. 71.0 grams of Cl2. Let's figure out how much product I could make if all my chlorine got used up. So first step is I'm going to convert from mass of chlorine to moles of chlorine. So my molar mass is 70.91. Then I'm going to use my mole ratio step. In this case, it is a 4 to 4 ratio, or you could simplify that to 1 to 1 ratio. Okay, and then I want to convert that to grams of my product. So what that tells me is I have enough sulfur to make 67.3 grams of product. I have enough chlorine to make 135.2 grams of product. How much product am I actually going to make? 67 grams. Because once I've made this much product, I will have run out of sulfur. So sulfur is my limiting reactant. And I'm going to have excess chlorine left over at the end. So, all right, so next problem is what mass of that excess reactant will be left over when the limiting reactant is all used up? So there's a couple different ways of approaching it. One way of doing it is to think about what your limiting reactant is. So that's 32.0 grams of S8. So the question you could ask yourself is say, well, if I use up all 32 grams of S8, how many grams of chlorine would get used up? So basically it's a grams S8 to grams chlorine problem. And that'll tell you how much chlorine is used up. Then you can do some subtracting to figure out how much will be left over. Okay, so if we think about this, you want to figure out how many moles of S8 there are. So again, molar mass is 256.6. And I'm going to make sure I label this. Okay, so every 1 mole of S8 is going to need 4 moles of Cl2. And every 1 mole of Cl2 weighs 70.91 grams. So what this means is in order to react all of my sulfur, I need 35.4 grams of Cl2. I have excess Cl2. I have 71 grams. So how much is left over? 71 grams minus 35.4. I have 35.6 grams of Cl2 left over. So that's just another variation on a Stoich problem there. All right, problem number 6. This is a percent yield problem. All right, problem number 6 is a percent yield problem, and percent yield is the actual yield, what you actually get in a lab, divided by your theoretical yield, which is what you calculate. So it looks like in this problem, I'm given a value of reactant here, and we say are given a percent yield. And what do you expect your experimental yield to be? So it looks like it's not super clear like what our product is that we're looking for, but it looks, if you look right here, this reaction disulfur dichloride, it looks like that's what we're aiming for. So we're trying to make S2Cl2. Okay. So what would your experimental yield of S2Cl2 be? Well, we're given a percent yield. This is given. And we are trying to find the actual yield. So it looks like we're going to need to calculate the theoretical yield. And how do I calculate a theoretical yield? Well, I do some stoichiometry. So I'm going to look back at the problem and say, what am I given? Okay, I'm given 5.23 grams of SCl2. And this is a percent yield of S2Cl2. So I'm going to try and convert from SCl2 to S2Cl2. Okay, so my first step is going to go from grams to moles. So I'm going to look up the molar mass of SCl2, and I will find that it's 103.0 grams. And remember, I'm trying to find this guy right here, S2Cl2. So I'm going to look at my mole ratio. It takes 3 SCl2s to make 1 S2Cl2. So it's a 3-to-1 mole ratio. And then every 1 mole of S2Cl2 has a molar mass of 135.0 grams. So if I calculate that all out, 2.28 grams S2Cl2 is my theoretical yield. Okay, so remember I said my percent yield is 65%, so I'm going to convert that into a decimal here. My actual yield is 2.28. Sorry, my theoretical yield is 2.28 grams. So this is my percentage, and I'm trying to find my actual yield. So my actual yield is basically 65% of what I should get in theory. So my actual yield is going to be 1.5 grams. And the reason why there's 2 sig figs there is because there were only 2 sig figs right here in the percentage that was given. All right, last problem we're going to go over here, number 9. This is a solutions-based stoichiometry problem. So 2-part problem here. Let's see, we've got a chemical equation which you need to balance, and when you balance it, these are the coefficients that you should get. So this again tells you like the recipe. So it takes 2 hydrochloric acids for every 1 magnesium hydroxide to make 1 magnesium chloride and 2 waters. So let's look at this first problem. We are given some information for HCl, and we're trying to find m grams of magnesium hydroxide. So it looks like we're given a volume and a molarity of a solution. You want to remember that molarity is moles per liter. So if you were given a molarity and a volume, you can find moles. Okay, so in this problem, let's see, our molarity is 4.0 molar. Our volume in liters is 0.0350 liters. So if you multiply it together, we have 0.14 moles of HCl, and that's going to be 2 sig figs there. I'm trying to find magnesium hydroxide. So my next step is going to be to use that mole ratio. So I know for every 2 HCl's, I'm going to need 1 MgOH2. So 2 to 1 mole ratio, that means that I need 0.070 moles of MgOH2. I just kind of put my answer down here. So first step, I went from volume to moles. Then I used the mole ratio as my second step. And then final step, I'm trying to find grams. So I'm going to go from moles to grams using the molar mass. So 58.3 grams is the molar mass of magnesium hydroxide. So 4.1 grams is my mass of magnesium hydroxide. All right, and let's take a look at the second problem. We're given a mass of magnesium hydroxide and we're given a volume, and we're trying to find a concentration. So we're trying to find concentration, remember, and that's moles per liter. The volume you are given, so that means we must need to calculate this part, calculate the moles of HCl. And we have a stoichiometry problem here. We're given some value about magnesium hydroxide. We know the mole ratio between HCl and magnesium hydroxide, so we should be able to do this using some stoichiometry. Okay, we've got 20.0 grams of magnesium hydroxide. First step, whenever you're in doubt, notice our first step is always to find moles. If you're not sure what to do, find moles. So 1 mole of magnesium hydroxide weighs 58.3 grams. And then we're trying to find moles of HCl, so I'm going to use my mole ratio. And again, notice every problem has involved a mole ratio step. So every 1 mole of magnesium hydroxide requires 2 moles of HCl to react. So if I stop and solve for this, I end up with 0.686 moles of HCl. And the problems asks me for molarity, and the molarity is the moles, which we just found, it's moles of HCl, divided by the volume of HCl, which is 0.130. Make sure you convert that into liters, and it looks like we have 3 sig figs there. So that would be my final answer. Please send me an email if you have more questions or requests for other problems like this.